What you can see here is a plan of a building, and we want to calculate the moment in one of these beam in our system. For example, this is the beam. We are going to calculate the unfactored moment on it. Hi everyone, structural analysis calculation. So in our example, we have like a system of a slab and beams and columns, and we want to calculate the unfactored moment in one of the beams in our system. So a floor plan of a building consists of a 12-inch normal weight concrete. Consider live load of 100 pounds per square feet applies to the system. We want to calculate the maximum unfactored moment which applies to beam B1. This is beam B1. Considering the unit weight of normal concrete is 150 pound per cube feet. Ignore the self weight of all beams and columns, and all beams are simply supported. Those are the conditions, and also the dimensions are provided for beams, slabs, and also the columns. The slab's thickness is 12 inches or 1 feet. We want to calculate the maximum unfactored moment in beam B1. In order to do so, we need to consider our system with the dimensions on it. And first of all, we need to go with the contributed area to beam B1. So if you go halfway through from each side, so this is 8, this distance is 8.5 feet, and the other one is also 8.5. So half of the length from this side, half of the length from the other side. So it makes it, because the distances are identical to each other, the this part is 8 feet and 6 inch, or 8.5 inch, 8.5 feet in this direction, and 13 feet point 4 inches is almost 0.33 feet. So this is our attributed area for column B1, and we need that for our calculation for load and moment. Normal weight concrete is 100 pound per feet cube, and also live load in problem statement is provided to be 100 pound per square feet. So let's jump to our calculation. So in terms of doing our calculation, we'll have our attributed area, and for moment in beam B1, we have all the information we want. And also in problem statement, it says all the beams are simply supported. So if this is beam B1 and there is a load on that, W stands for total load. We need to separate that for each part, live load and dead load. Total load comes from the W sub D plus W sub L. Dead load plus live load. Our dead load is 150 pound per feet cubes times the thickness of a slab, which is 12 inches converted to feet, and then multiply by the widths of attributed area, which is half of this part and half of that part, and it means 8.5 over 2, that make it a 8.5 feet. And if you do the math, it just gives you 1,275 pound per feet. That's the distributed load over beam B1. And also live load is 100 pound per feet squared. And if you multiply it by, again, the width of attributed area, which is 8.5, it just gives you a live load of 850 pound per feet. If you add them up together, total load is dead load plus live load, and it just make it like 221.25 pound per feet. That's the distributed load over the entire span of B1. And if we have the total load, this is the load and shear and moment for a two simple supported beam. And you can easily see the length comes from this part, that's 13 feet and 4 inches, which make it like L equal to 13.33 feet. Maximum moment is come from WL squared over 8 for such beam, and the total load we already calculated to be 2125 pound per feet. If you replace this W in our equation and do the math, it just gives you maximum unfactored moment. And by unfactored we mean we didn't apply 1.2 dead load plus 1.6 live load, and we just it's just simply the summation of dead load and live load, and without using the factor, that's unfactored moment. And it just makes a maximum unfactored moment of 47.2 kilopound feet. And if we just jump to our multiple choice the question, that's an interesting question, and it just gives us a numerical calculation of maximum moment of 47.2 kilopound feet, and the correct answer is C. Thank you. We'll solve more problems in structural analysis and seismic analysis.